So, welcome everyone. Welcome to the session on strength of materials. Right. So, this is a playlist where the topics on strength of materials will be discussed. So, this topic, that is, this video is specifically for moment of inertia. We have already discussed about center of gravity, and if you have not watched the center of gravity, it is available in the playlist. Just check out and watch the topic, right? Okay, now let's begin the session. Before going into moment of inertia, I need to give you a simple piece of information that is very necessary here. That is about Unacademy Combat. So India's largest weekly competition, which is happening, and today at 11 a.m., which was kickstarted, right? If you have not attended, you can attend it, right? The importance about this Unacademy Combat is, right? It is India's weekly largest competition exclusively for GATE, and more important thing, it is typical kind of GATE questions will be there, that is original GATE questions you can be taken out, and it is selected by the India's top educators, and live leaderboard will be provided, so you may know that where you are once you are answering the questions. After the session, you'll have a detailed video solutions to find out your weakness and what is the mistakes that you have find out, and you can attend it completely free by using the code PSK20. If you use the code, it's completely free to attend it. And next is, if you get a good rank in this Unacademy Combat, that is from rank 1 to 3, you would get complimentary 1 year plus subscription completely free. And if the rank is 4 to 10, then you would get 75% of offer while getting subscription, and rank 11 to 50 you will get 50% of subscription, and rank 51 to 100 you will get 25% of subscription offer. Right now, these are the few students who got good rank in GATE 2021 under the category of mechanical, production and engineering science. Right. There are two types of subscriptions. One is plus and another one is iconic. In a plus subscription, you have an access to the live classes, crash courses will be there, and every week you'll have a weekly test. That is, you can verify what you have studied on an every week basis, and doubt solving session will be there, and the sessions will be in both English and Hindi, and with RIB will be provided. Okay, right? And this is for plus subscription. If you are going for an iconic subscription, you will have all these 6 parts. Apart from that, additionally, you will also have a study planner, right? So study planner means a customized study planner which is based on your previous performance, right? So based on your previous performance, the study planner will be made, so you don't need to worry whether it is a common one or it's exclusively for yourself. And personalized coach will be there to guide you to make a perfect preparation strategy, and doubt clearing instructors will be there to clarify your doubts, and preparatory materials will be provided, so you can download it as a PDF and you can make it for your preparation purposes. Study booster sessions will be there to boost your marks with the regular workshops, and guidelines will be provided to attempt the competitive examinations, and personalized test analysis will be given. That means in-depth micro level analysis about each section and question type will be given, so that you can identify your weakness and improvise it. So these are the advantages in iconic subscription. So whatever subscription you take it, right, do it immediately, because price is going to be increased. Price hike is there for a GATE and ESE category from July 1. So that means you are having another 3 days only. If you are planning, do it immediately. If you use the code PSK20, you will get the maximum discount for the subscription, right? Okay, and while going to the subscription, you can see that if you use the code PSK20, immediately the discount will be reflected here. Okay, so this code is applicable for all categories. Now, most important thing, on 23rd June 2021, that is 4 days back, a batch course that has been kickstarted. So what is the advantage of this batch course? Means if you are planning for 2022 or 2023 GATE and ESE examinations, a perfect study plan has been made. That means every day you have to spend 2 to 3 hours of time to study it. If you spend it and in this batch course, so you don't need to worry about any other courses or any other thing. So everything comes under this one batch course. So it was perfectly planned that if a student who has spent it or who has followed this batch course, he can get a good marks in GATE, because the course starts from the fundamentals, theory part, numericals, MCQs, previous year questions, everything will be perfectly covered. So you don't need to search out any other courses. If you follow only this batch course, then everything will be there. So if you need to go for this batch course, PSK20 is the code, so that you can enroll it and you can study it freely, right? Now, next we are moving into the our part, that is moment of inertia. So as I mentioned already, we have discussed about center of gravity in the previous session. So we are directly moving into moment of inertia. Okay, so to find the moment of inertia, the first step is you have to calculate the center of gravity. That is the first step, right? Then only you have to move on to the moment of inertia. Okay, so as I have already given 7 steps. Step 1 is split into simple components, split the shape into simple components. So first step, I am splitting this T section into a 2 simple rectangles, that is rectangle 1 and rectangle 2. Second step, draw the XX and YY axis. So the YY axis is already there and I am drawing the XX axis. Drawing the XX axis. Next thing is, after drawing the XX axis, find whether it is symmetry or not. That is, find the section which is symmetrical about XX and YY axis. That's the next part. Okay, so according to that, if you check out about YY axis, yes, the T section is symmetrical. T section is symmetrical on both sides. But if you check out about XX axis, no, it's not symmetrical about XX axis, because on top side we have a web, on bottom there is nothing here. Okay, so about T section, it's not symmetrical about XX axis, right? According to that, next step is mark the origin point. So marking the origin point O, right? Next thing, find the area. So area of rectangle 1, where the value is A1, that is equal to 150 into 50. into 50, right? So first you have to find the area of two rectangles. So first rectangle 150 into 50, that is 7500 mm square. Next, area of rectangle 2, A2, that is equal to 150 into 50, that is 7500 mm square. That's the first work. Next work is y1 and y2. So if this is the CG, then y2 y1 y2 y1 y1 and y2 you have to calculate it. So According to that, y1 means from the origin O to 150 plus 50 by 2, that is 25. So it is 175 mm. Y2 value is 150 by 2, that is 75 mm. That is 75 mm. Right. So yeah. So based on this, now if you calculate the y bar value, that is a1 y1 plus a2 y2 divided by a1 plus a2. So the values are 7500 into 175 plus 7500 into y2 value is 75 divided by 7500 plus 7500. So the y bar value is 125 mm. Now what is this 125 mm? From the origin, the height of x axis is 125 mm. And exactly at the meeting of x and y axis, you get the center of gravity of this total section. Okay, right? So now you have calculated the y bar. From there, CG of the whole T section is calculated. So well and good, nice. Now what you have to do, right? You have to calculate the moment of inertia. For that, the first step is we have calculated the center of gravity. Now we are moving into the moment of inertia. So for that, again we have to split into two rectangles, right? So rectangle 1, rectangle 2, and also we have to do it for both axes, that is about x axis, about y axis. So here very important point is about y axis, the component is symmetrical, so it's easy to calculate the y axis, but about x axis it's not symmetrical. So let us calculate it here. So xx y2 y1. Okay, so r is even okay, right? This height is 125. Okay, right. One 75 and 75, right? So now it's clear, so it's easy to do it, right? Now going to moment of inertia. Before moving to moment of inertia, first we are calculating moment of inertia about x-axis axis. So first our approach is about x-axis axis alone. We are not going to do it about y-y. Our first aim is to find it about x-axis axis. For that, the first step is rectangle 1. In that x-axis axis, first step is about rectangle 1. For that, first IG1. So what is this IG1 represents? Moment of inertia about its own center of gravity of rectangle 1 about x-axis axis. Got it? IG represents moment of inertia about its own axis for rectangle 1 about x-axis axis. Okay, so rectangle 1 is here, rectangle 1, rectangle 2, right? So rectangle 1 about its own CG is here, and rectangle 1 about its own CG from x-axis axis. That's the first point. So about its own axis means BD by 12. That is equal to the breadth and depth values 150, 50, 150, 50, right? $150 and 50. So this is 50 and 150, right? So now 150 into 50 cube about, yes, yes, correct. 150 into 50, that is breadth into depth, 150 into 50 cube by 12. So BD cube by 12 is moment of inertia for a rectangle equation. So from there, if you calculate it, you get the answer, that is 1.5625 into 10 power 6 mm power 4. Right. Now, next you have to calculate H1. So what is this H1 value? From the x-axis axis to the CG. This is H1. Right. From the x-axis axis to the CG of rectangle 1. This is H1. Now, from the origin, x-axis axis is 125. From the origin, x-axis axis height is 125. From the origin, CG of first rectangle is 175. So 175 minus 125, we would get the H1 value. Right. So 175 minus 125 is 50 mm. Now we will get the value of H1, and finally with these values, right, for rectangle 1 about x-axis axis, IG1 plus A1 H1 square, right? So you can find that IG1 plus A1 H1 square, that is 1.5625 into 10 power 6 plus A1, that is area 1, already we have calculated. Both areas are same, that is 7500 into 50 square. Right. So the final value is 20.3125 into 10 power 6 mm per 4, and this is the moment of inertia of rectangle 1 about x-axis. Right. Next, rectangle 2. For rectangle 2, same IG2 BDQ by 12. So let's take it as B1 D1. This is B2 D2 because of rectangle. So for the second rectangle, breadth is 50, depth is 150. Okay, so which means 50 into 150 cube by 12, that is equal to 14.0625 into 10 power 6 mm per 4. Right, so according to that, next H2 value, next is H2 value. So what is H2 here? From the x-axis up to the CG of second rectangle. So from the x-axis to the CG of second rectangle, this part is H2. Okay, this is H2. Now H2 means from the origin, x-axis is 125. From the origin, CG of second rectangle is 75. So how can we calculate? That is 125 minus 75, that is 50 mm. That is 50 mm. So now we have calculated these two values. So obviously for rectangle 2, IG2 plus A2H2 square, that is 14.0625 into 10 power 6 plus second rectangle area is 7100, H2 value is 50 square. So the final value is 32.8125 into 10 power 6 mm per 4. So here the final answer, moment of inertia about x axis, that is equal to moment of inertia about x-axis, that is equal to first rectangle plus second rectangle. Okay, first rectangle plus second rectangle, that's it. Okay, so which means three 125 into 10 power 6 plus 32.8125 into 10 power 6, that is equal to 53.125 into 10 power 6, mm/4. So this is the moment of inertia about x axis. Now next part is moment of inertia about y axis. So this is very simple one. Why? Because about y axis the component is symmetrical. About y the component is symmetrical. So you don't need to have the value of h1 and h2. You can see if h1 value is not there, then moment of inertia about own axis, that is enough. So simply we can calculate, right? So based on that, for rectangle 1 Ig1, that is d1 b1 cubed by 12, because it is about y axis. About y axis, you can see depth into b cube is the right representation. So depth is 50, breadth is 150. So in that case 50 into 150 cubed by 12. So that is 14.0625 into 10 power 6 mm power 4. Similarly, for rectangle 2 Ig2, now d2 b2 cubed by 12, where 150 into 50 cube divided by 12, and the value is 1.5625 into 10 power 6 mm power 4. So moment of inertia about y axis, that is, add these two things, 14.0625 into 10 power 6 plus 1.5625 into 10 power 6. So the total value is 15.625 into 10 power 6 mm power 4, right? This is the final answer here, right? So one of the simple method, if you understand the concepts, right? If you understand the concepts, it's very easy to answer it, right? So it's simple and easy, but you have to do practice. Multiple number of practice will help you to avoid the errors, right? So if you are not having any practice, surely error may occur. So do practices to avoid the errors, right? So this is for about y axis, and here this is for a x axis, right? So in this question we have done moment of inertia. We have calculated moment of inertia about both x-axis and y axis. In case if any axis which was specified, if any other axis, any other plane is specified, then how to calculate it, right? So let's do the problem next. Okay. So here you can see this is a specified one, right? Specific problem where you have to calculate moment of inertia about kk. Okay, you have to calculate moment of inertia about kk. So a specific plane is provided. Based on plane, you have to calculate the moment of inertia. That's the question. Okay. Now, according to that, when a specific plane is provided, you don't need to find out the center of gravity for this whole component. Okay, so you don't need to calculate center of gravity for a whole component. Just find the CG of its own, that is enough. Right. So let me do it. First, split into simple shapes and rectangle 1, rectangle 2 is marked. Now, next step is draw the x and y axes, whether find out it is symmetry or not. If it is not symmetry, all those things we are omitting because we don't need to find the center of gravity, right? So everything is omitted. Just a simple thing that find its own CG. Find its own CG. Find its own CG. So once its own CG is calculated, next point is find the length. H2 H1 H2 H1. Okay, right? So that's the next one. Once H2 H1 is calculated, moment of inertia about its own CG, then with these things we will calculate about KK. Right? So let's move on. Here moment of inertia about its own CG, that is IG1. IG1. Okay, so that is equal to, here dB³ by 12 you have to select it. Why dB³? Because KK axis is vertical, right? KK axis is vertical, that means which is parallel to YY axis. If it is YY axis, we will use dB³. That's why we are using dB³ equation. So depth of first rectangle is 120 and breadth is 40. dB³ by 12. So that is equal to 640 into 10 cube mm power 4. Same way, IG2, that is equal to D2B2³ by 12. Depth 2 is 40 mm. Breadth is 240³ by 12. Right. So once you have calculated, you have calculated 10 power 6 mm power 4. Right. So with these values, our next work is to calculate H1. H1 means from the reference axis to its own CG. So from the reference axis KK to the surface is 100 mm. It is specified from KK axis to the surface is 100 mm. This 100 plus 40, total width is 40, divide by 2. 100 plus 40 by 2, that is 120 mm. Okay, so going to the H2 value, that is from the 100 to the surface, 100 to the surface. From the surface, total distance is 240, divide by 2, 120. So 100 plus 240 by 2, 220 mm. Right. So once these two values calculated, then we have to calculate Ig1, that is no, we have to calculate the area here. Yes, area 1, that is area of rectangle 1. So 120 into 40, right? Area of rectangle 1, 120 into 40, or even we can write it directly. So rectangle 1, Ig1 plus A1 H1 square, that is 640 into 10 cube plus 120 into 40, that is area, into H1 is 120 square. So that's the value. The value is 10 power 6 mm power 4. This is for rectangle 1. This is for rectangle 1. Now rectangle 2. Ig2 A2 plus Ig2 A2 H2 square. So Ig2 is area 2 is 240 into 40, right? H2 value is 220, right? So which is equal to 72 into 10 power 6 mm power 4. So the answer is 510.72 into 10 power 6 millimeter per 4. Now the final component, the final show is moment of inertia about KK axis. Moment of inertia about KK axis is for rectangle 1 value, that is 69.76 to 10 power 6 plus 510.72 into 10 power 6. The total value is 580.48 into 10 power 6 mm power 4. So this is the moment of inertia about KK axis, right? Got it? Right. So another super simple question. So if a specific axis is given, how to calculate it, where we are done it. So if a specific axis is given, you don't need to calculate the x-axis or y-y axis or center of gravity. Directly you can go for moment of inertia, right? Good. So let's do one more a simple question aloud. Here we are going to find out moment of inertia about only x axis. We are going to calculate only about x axis, right? Good, great. So first I'll quickly on. First find center of gravity. For that I'm quickly moving here to find center of gravity. First find A1, that is area of rectangle 1, that is 60 into 20, so 1200 mm square. A2, area of rectangle 2, that is 100 into 20, that is 1000 mm square. Area of rectangle 3, 100 into 20, again 1000 mm square. Sorry, it's square. Right. Next, y1 value, that is y1 value means from the origin to the CG. So here from the bottom 20 plus 100, 120 plus another 20 by 2, 10, right? So 20, 100 plus 10, totally 130, right? 130 mm y2. So 20 plus 100 by 250. So 20 plus 50, that is 70, 70. Y3 is 20 by 2, 10 mm, right? So now with all these values, you can calculate the y bar, that is A1 y1 plus A2 y2 plus A3 y3 divided by A1 plus A2 plus A3. So 1200 into 130 plus 1000, sorry, it's 2000, right? 2000 into 70 plus 2000 into 70 divided by 1200 plus 2000 plus 2000. So which is equal to 60.8 mm, which is equal to 60.8 mm. So 60.8 means the position of x-axis, right? The position of x-axis is 60.8, right? Now from here we have to calculate the moment of inertia about x-axis, right? So it's all about moment of inertia about x-axis. It's all about moment of inertia about x-axis, right? That's what we have to do. So for that, first step, let's go step by step. First, Ig1 B1 D1 cube by 12, where breadth is 60, depth is 20. Breadth is 60, depth is 20. So 60 into 20 cube by 12, that is equal to 40 into 10 cube mm power 4. Next, h1 value. So h1 value means from the x-axis to the point, that is to its own CG. So this is h1. Now we know that from the origin height is 60.8. From the origin to the CG we have already calculated it is 130. So 130 minus 60.8. 130 minus 60.8, and that is equal to 69.2 mm. So now you can calculate the value of rectangle 1, that is equal to Ig1 plus A1 H1 square, that is 40 into 10 cube plus A1 is area of first rectangle is 1200, 69.2 square, which is equal to 5786 into 10 cube mm power 4. Right, this is for a first rectangle. Right, this is for a first rectangle. Similarly, for second rectangle IG2, right? So here B2 D2 cube by 12, B2 D2 cube, that is breadth is 20, and depth is 100. So 20 into 100 cube by 12, that is equal to 166.7 into 10 cube mm power 4. And next is H2 value from x-axis to the own CG. So from bottom, right, from bottom this distance is H2. This is H2. And this is H3, right? So now from the x-axis to the CG of second rectangle, so that is equal to 70 minus 60.8, that is 9.2 mm. So finally, for rectangle 2, Ig2 plus A2H2 square is equal to 1666.7 into 10 cube plus 2000 into 9.2 square, that is equal to 1836 into 10 cube mm power 4. So based on that, right, next is Ig3 for third rectangle B3 D3 cube by 12. So B3 D3 for a third rectangle, breadth is 100, depth is 20. So 100 into 20 cube by 12. So for that you can calculate 66.7 into 10 cube mm power 4. Now H3 value is from x-axis to the bottom, and it is 60.8 and 10. So 60.8 minus 10, that is 50.8 mm. So based on that, now for a rectangle 3, that is IG3 value is 66.7 into 10 power 3 plus area is 2000 and H is 50.8 square. So then the value is 5228.8 into 10 cube mm power 4. So this is the third rectangle value. So about IXX axis, if you substitute it from the first 5786 into 10 power 3 plus 1836 into 10 power 3 plus 5228 into 10 power 3. The total answer is 12,850 into 10 power 3 mm power 4. So this is the total moment of inertia about XX axis for the I section. Right? So one of the simple technique, simple questions. Got it? Right? So thank you everyone. We will see you on our